Hi, my name is Sophia, and we're out at the Beaumont Scout Reservation in St. Louis, Missouri. And what we want to show you today is how you can apply science to just the playground equipment that you might have in your neighborhood and be able to bring science to your scouts when you kind of go through the activities everywhere. So today we're at a playground, right? So do you guys normally think about science at a playground?
No.
Are you sure?
Yeah.
Okay. Well, let's see. We're gonna explore some ways of being able to demonstrate science here at the playground. And so one of the things we're going to do is first just kind of look at you guys. You guys are all varying height, right? We've got Bo here is the tallest, so Nate here is the shortest, and then we've got JP who's kind of in between. But we've also got some variation in their uniform, so it'll be interesting to see how that makes a difference in our test here that we're going to do, how we're going to apply science to this adventure here. So what we're going to do is we're actually going to go down a slide and demonstrate on the slide science. So first of all, what I want to do is talk about the features of the slide. So this slide that we're looking at behind Nate right now, or behind Bo right now, is just a little bit taller than you, right? What are some things about the slide that you guys can see?
Well, there's bumps in it, it's yellow.
Bumps in yellow. Okay, what else?
That there's a little bridge over it.
Okay. How about the material? What's it made out of?
Made out of like plastic, but then if you look at the bottom, there's a little bit of metal.
Okay, all right. So the entire slide here is plastic. So unfortunately, we don't have different materials to kind of mess around with, but at least we've got a plastic one. So what I'd like you guys to do is go ahead and go up to the top of the slide, and then one at a time, we're going to come down the slide. Okay, and then what we're going to do is we're going to time you guys as you're coming down the slide just to kind of get a sense of how fast each one of you would go down the slide, and then we can kind of talk a little bit about why we think the speeds might differ. Okay, so when he gives you the mark, then you go down the slide.
Should I push?
Nope, no pushing.
No pushes. On your mark. Get set. Slide. 1.44 seconds.
Okay, remember that.
JP, on your mark. Get set. Slide. 2.29 seconds. Nate, on your mark. Get set. Slide. 1.79 seconds.
All right.
So who was the fastest?
It was. Okay. All right. So let's talk about why we think that you might have gone faster. Because one of the things that sometimes people will say, well, you'll go faster if you weigh more. You'll go faster if the slide is smooth and straight and maybe is very slick, right? So what do you think might be the reason?
I think it would be that Nate went the fastest because he's the smallest, so he has less weight, and that means less friction because he's pushing down less. And then Bo, I would have thought would have been the slowest because he's the tallest and he would have had more friction.
Okay. All right. What other things do you think might change?
How shorts? Because I have khaki shorts. He
Okay.
has Boy Scout, whatever shorts. I have like basketball shorts on.
Okay.
So like they're more slick than khaki shorts.
Okay. All right. So what do you think you would change then? Is there anything that we could change today to change the way you go down this slide? What do you think you might be able to do?
I put my back on it.
Okay, so if you were to lay straight, so what do you think that would do then? If you were to put all of your body on the slide, what would that change about you going down the slide?
Maybe it would make me go quicker or slower.
Quicker or slower, okay? What do you think?
I think it would probably make him go, or any of us go slower, because that means there's more, there's more weight, and that means there's also more friction.
Okay.
That means there's more areas.
Okay, good. You said more area, so that's good because that means there's more surface area that would be against the slide, and so that would cause more friction. Good. How about you?
So I think it would be slower because with only one part of the body on it, that little bump would make your body stop a little then go. But when you're facing down or flat, it would make it go longer stop.
Okay, right, because you have more of your body kind of in contact with the slide. So do you think that if you were to go down a straight slide, would that change? Would that change it?
Mm-hmm.
What do you think would happen if you went down a straight slide?
Well, like at water slides how like they'll go straight down sometimes, and then that might go quicker.
Okay. And so that's something that's interesting that you brought up too. So what's different about a water slide versus a slide you just went down?
Water makes you go quicker because it's all slippery and you just win.
All right. Very good. Okay. So that's science relative to a slide. All right, so now we're at the swing set. So we demonstrated the slide. Now we're going to talk about potential and kinetic energy. So tell me what you know about potential and kinetic energy. Yep.
Potential energy is when you pull the swing back, and then kinetic energy is when the swing is actually in motion going forward or swinging backwards.
Okay. And what's another example of potential energy, though? Not just pulling it back, but what would be another situation where you have potential energy? Yes.
When you hold up a bouncy ball and you hold it over the ground, and then when you drop it, you get kinetic.
Very good. Right, right. And actually, just you guys sitting there, just the way you are right now, that's also kind of a demonstration of potential energy as well. All right, so can you demonstrate potential energy? You can pick either one of your friends here as to which one you want to demonstrate potential energy. Okay? All right, so that's potential energy, energy that's stored up and ready to go. Now, let's demonstrate kinetic energy. All right. So now the act of going back and forth, you've released it, and so now they're actively moving, so that's the kinetic energy. All right, Bo, can you demonstrate too without, you don't necessarily have to have JP pull you back, but, so that's potential energy right there, and now kinetic energy, right? And so what can you do to increase the energy of the swing?
Pump my legs.
Pump your legs, right? Yes.
And then also when you swing your legs, it's also because it's pushing, when you swing it out, that adds more force forward,
That's right.
which lifts you up higher, which also makes there be more force in the back, which also makes it so you end up having more, and that's how you get higher.
Right. So what other things could you do if it's just not just the pumping of your legs, but what other ways could you inject force into the system, into the swinging action? What else can you do?
You can, when you let go, you can push them also.
Right, you can push them. So all of those things kind of contribute energy into the system. So that's also demonstrating science in the park with the swing set. All right, so then the next thing you could do out at a park is demonstrate a scale model of a solar system. And so I've got my assistant here again to help demonstrate. So what we're trying to figure out is how to imagine and envision the scale of our solar system. And so what we've done is we've actually had the scouts spaced out where they are along the line. And we have our leader over here representing the sun. If you want to raise your hand. The sun shining brightly across all of the scouts there. And then we've got Nate representing the 4 planets that are really close to the sun. And in the order. So Nate, can you tell us which planets are really close to the sun?
Venus, Mercury, Earth, and Mars.
All right, so Mercury being the closest, then Venus, and then we've got Earth, and then we've got Mars. And so they're the ones that are really, really close, and they're actually also some of our smaller planets that we have. And what I'm not showing in between Mars and the next planet here, which is Jupiter, which you can see is quite a bit of distance away, is we actually have an asteroid belt that's in there too, about halfway between Mars and Jupiter. And then next is Saturn. So you can kind of see about how far away it is from the sun, slow sun. Okay, and then what's next is?
I have Uranus.
All right, and then way, way out there, way past the sun is?
Neptune.
Very good, Neptune. So what we want to demonstrate on this one is just to kind of let everybody get a sense of just how far away you really are. So Exactly, right? So let's get around the sun. 1 year, 365 days, or 365 days. And so then, if we were to look all the way out to Neptune, though, it's going to take a lot longer to be able to get all the way around that sun. So their year. Pardon me? I don't know that answer right off the top of my head. We'll have to Google that.
Google says a year on Neptune is 165 Earth years.
Did you hear that? So that's good that you're asking questions. And so part of what we want to do, though, is the whole point of exercises like this, coming out and looking at this, is really wanting our scouts to be able to ask those questions then, to really figure out what's happening in our world, and how do we continue to be curious and how to ask those questions. And so even if we as the leaders don't always know the answers, if we can make sure that we are contributing these types of science projects and these adventures for our kiddos, it'll help them be curious and ask questions about the world they live in. Now, if your scouts are really hungry, though, all the time, you can introduce a little bit of food into the fun of science as well. So what I have here is a picture of the solar system, not to scale, so that's okay. But what we do have, though, are some fruit items that would actually represent the right size for the planets. And so we're going to go ahead and lay out all the planets onto our solar system here. And then that way you can kind of get a sense of the size of the planets based on the type of fruit we have. All right? All right, so let's go ahead and lay out the grapefruit for the sun. Lay it out by the word sun. All right, so there we go. And then next we've got Mercury, which is going to be the blueberry. It is pretty small. There we go. All right, and now we've got Venus, which will be the raspberry. And then we've got Earth, which will be the kiwi. All right, and then we've got Mars, which will be one of the strawberries. You can put it down if you want to. All right, cool. And then now we're getting to the bigger ones, and so we're going to take the orange, which is underneath the apple slice there. Okay, so that's going to be Jupiter. And then we've got Saturn, which will be the apple, starting to get a little brown. All right, and then Uranus is going to be the plum.
Never had a plum before.
Never had a plum. So then the other side benefit of all this is introducing you to new fruit. Okay, and the last one will be the lime. And you put that onto Neptune. All right. So just wanted to kind of use fruit to kind of help demonstrate a little bit of some relative sizes. And then, of course, the really nice thing is then you get to eat it when you're done. All right, well, I hope that you enjoyed the segment and it encourages you to get out and explore your neighborhood and figure out how you can apply cool and interesting science activities with your scouts in whatever's nearby.